All right. Hi, everyone. My name is Aaron, and I'm curious, who here wants to really maximize the positive impact of the code you write by show of hands? So this is what I think about a lot. How can we do this? Because we're going to be writing code a lot. That's the career we've chosen. We are blessed to be able to do it. That's my perspective. And if we're going to do that, how can we maximize the good of what we're doing? And one way I've realized in studying different open source projects is that if we design a library, a framework that other developers can adopt and use and do so easily in a way that solves big problems, that is one way that we can extend the good of what we do. So I'm going to show you one approach for this in Python. And it's going to be exploiting something called magic methods. Who here has heard this phrase before, magic methods? Okay. There we go. Now, magic methods are hooks in the object system. Many of you have heard of these. And just to show you how it works, I made a toy library that on the surface looks like the pandas library, this data analysis library if anybody's familiar with that. Now, the way you use it is something like this. You say from fake pandas import a class called DataSet, and you create an instance of it like so. Notice that you're passing in 3 rows here, or 3 key value pairs in the dictionary to the constructor. These are labeled columns of data. So what you want to do mentally is take one of the rows of data and then rotate it in your mind. And that becomes a column that's labeled. That makes sense? With me? Great. Now, once we've created this DS object, I can then say ds.pprint, and we get a nice labeled set of data here, right? Small data, not big data, but we'll get there. So just looking at this data really quick, in the A column, how many values are positive? 3 of them. In the B column, what's the biggest number? What's the second biggest number? 14, very good. Now, what we want to be able to do is if we're designing a framework that other people can use for data analysis, we want to make it easy for them to do the things they want to do. Yes? So what we want to be able to do is say, okay, you can call, whatever, zoom this in just a little bit. What I want someone to be able to write is to reference DS and then with square brackets have an expression saying, give me the rows in this data set where the A column values are positive. And in fact, I get this object positive underscore A, which is another data set which I can then print out. So did this filter my rows according to the criteria here, right? There's no negative values in here. Now, here's another example. We can say, okay, give me the rows where the B column is greater than 14. Another example, give me the rows where the relationship between A and B is such that their total is less than 20. This is the interface in the library that I provided here. You notice how it's very natural syntax. This is not something that will take a long period of training to enable someone to be able to use it well. Agree? Yes or no? Pretty simple, right? So now if you think about it though, there's something a little odd here. Can anybody point out what's kind of unusual on the first line? The operator. Which one? The plus, the less than, or either, right? Right. Because what's in those square brackets is something that, just using the normal Python syntax, it's something that should evaluate either true or false, one of those 2 literals at runtime. And that is literally 1 bit of information. That is not enough information to filter out all the rows to get just the ones I care about. That makes sense? So what's going on? How does this even work? The answer is something I'm going to build to, but it exploits these things called magic methods. And many of you are familiar with this, and many of you are not. These are these double underscore methods. Usually we say, I like to use the word dunder as a shortcut. So I'll say instead of underscore, underscore, LT, underscore, underscore, I only have 10 minutes left, so I'm not going to say underscore that many times. I'm just going to say dunder LT. But we have this dunder LT method that if our class implements this method, it's a hook that lets it be used with the built-in less than operator. And so on for greater than, equality, all these. These are the magic methods that we're going to use, right? So in this angle class example, very natural, very mathematical. It's just 0 to 360 degrees. Very, very natural way mapping onto normal arithmetic, right? But we can cheat. We don't have to follow the normal conventions of having these methods return true or false. We don't have to do that. We can have it return anything. So we're going to exploit this to create a more usable syntax. Now, here's my DataSet class. This is part of the code. I'm going to show you pieces of how this is implemented. So the constructor is very simple. It has the data, which was that dictionary mapping the labeled names to the columns, right, sideways. We have calculate a length. This just checks the data, say, okay, how many rows do I have? And if it's inconsistent links, then I raise a value error. That's what the numRows function does. And then we say self.labels. I'm going to sort the keys and store that separately just for convenience. That's all that's happening in the constructor here. Now, next thing we want to do is we say, okay, if we have a column that's labeled A, I want to reference ds.a, capital A, and get a label reference object. That's what I'm calling this. So what does that class look like? Well, actually, how do we even get there? We implement dunder getAttr. That's how we say .a. That's how we dynamically look at what the label is, the A, B, C column, and then get the label reference object. Now, we return that label reference class. What's in there? That is where we put our hack. That is where we misbehave and put in a magic method that doesn't do what it's supposed to do. We say dunder greater than GT method. It returns an instance of something called comparison. Notice the arguments that are passed in. We pass in a label. That's just a string. Value, that's what is being compared to. When we say ds, and then in square brackets, ds.a is less than 0. That would be 0 here, or 3, or whatever the number is. And finally, we pass in a function object, operator.gt. That's a binary function that will implements the logic we want. Now, how do we represent this comparison itself? We say, okay, well, we just pass it into a constructor, and we have a method called apply, because all this is lazy. All this means we don't evaluate it at the very beginning. We only evaluate it when we say, give me the rows of data, I want them now. That's when apply is called. And it uses that operation, that binary function we passed in, to filter the data rows. Okay, so this is more about let's look at the comparison class a little bit more. You have the constructor, and then you have about the apply thing. The key thing to understand is it's done on a row by row basis. So it returns true or false. This actually returns true or false. That's where the true or false logic is finally surfaces. So here's a recap actually I'll skip over this. Okay, the only thing left actually, so we're going down a rabbit hole here, right? We're just going down this rabbit hole. So let's go back up to the top again. How do we make the square brackets work to begin with? When we say ds, square brackets, and then put in this thing that looks like a Boolean expression, but it's not really a Boolean expression. Well, we just use the getItem under getItem method, and we have within it, I won't read this code. You can read through it yourself, or I'll give you a reference to it for later. And you can see what it's doing is it's constructing a new data set with just the rows we care about. That's what it's doing. Now, we can go further with this. All I just showed you was just for a simple thing. Give me the rows where this row's value is greater or less than or whatever this reference value. But what if we want to express relationships between multiple columns? adding or subtracting, multiplying? What if we want to implement logical and or relationships, much more complex relationships? What if we want to have more equation-like filters? Like here's this y equals, basically the C column plus 2 is less than what's in column B. We can do all of this. And I won't make you do it. Should I? Nah. Here's a source. So what I did is I implemented all this. So you can just go, I go by the nickname red symbol online, different places, including GitHub. So if you look under there, you'll see fake pandas. This is my contact information. In closing, I just want to say, if anyone here would like me to speak at your group or organization, get in touch. If you have questions, find me later. Thanks a lot.